Hi guys, in this first video on simple linear regression, we're not even gonna get into the simple linear regression model. We're gonna first start by talking about the type of data that we're going to be confronted with, and that is called bivariate data. And what bivariate data means is that we have a set of measurements or observations on two variables. So we don't have just one variable in the univariate case. We have two variables. So for example, let me just briefly write what I said. Two measurements. So we're measuring two things on each observation. So we have two variables, but it's not just two distinct variables. They're connected in the sense that on each person, place, or thing that we're measuring, on each observation, we measure two items. We collect two variables. So we have, in generic terms, we have an x variable and we have a y. We tend to use these guys as the placeholders until we have more concrete examples. So we have an x and a y variable. So let's say our x variable is a person's age, and the y variable we're measuring is their height. So not only are we measuring someone's height, but we're also recording how old they are. So we randomly select n people. So here's a sample of observations. This is just this column here is just the counter. Okay, so we have these are, each one of these rows represents a person. So we randomly select n people. We record their age. So let's say this person was 27 and he or she was 5'6". And we collect a bunch of others all the way down to the last person who maybe was 21 and they were 6 feet tall. Okay, so each one of these rows is connected to one person in this case, but more generally to one observation. That's bivariate data. Now, if we confine both these variables or constrain them to both be numerical, like in my example where age and height are both numerical, we'll have just bivariate numerical data. Okay? And this is precisely what we're going to be dealing with in this series of videos. So in this module, where we're going to eventually be talking about correlation and simple linear regression, bivariate numerical data specifically is what we're going to focus on. So here's an example of that. Two variables measured on each observation, both of them being numerical. Okay? If this is the case and we have data like this, you can already see that we can focus on one of the variables and ignore the other one for the time being and just ask, hey, what was the average age of these people? What was the variance of the age? What was the standard deviation? What was the range? What does the distribution look like? Is it bell-shaped? Is it uniformly distributed or skewed in some sense, right or left? Well, we could answer all those questions using all the techniques that we've learned in our introductory stats courses, right? And we could do the same thing for height. We could look at height alone, univariately, right? And ask pretty much the same questions I just asked of age. And that will shed a lot of light on the variables individually. But as soon as we have two variables, an x and a y, we can ask, are they related in some special way? And that's where having two variables makes things more interesting than having just one. We can ask, is age related to height, or is height related to age? Same thing. And we can actually learn about that relationship if there is one. Okay, so the next video I'm gonna actually go into the first few tools we have at our disposal to learn about whether there is relationship or not. So watch part 2 for that. Before I leave this video, I want to just show you some bivariate data sets in a more computer setting, like a spreadsheet setting. So here you see we have an x and a y. At this point, it doesn't matter which variable I call x and y. Here, house price in thousands. So this house is $245,000, and it was square foot is the other variable. It was 1,400 square feet. So this row right here represents one house, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I believe, rows. So n is 10 here. So we still have this concept of a sample and a sample size, which we use n to notate, except now there's 2 variables measured on each of the observations. So we can go over to this example here, and we see we have something related to shelf space, probably retail shelf space, and sales. So how much shelf space you're dedicating to a certain product and how much sales you have, maybe after a month or so. So without more information, we can't really tell what's going on here, but that's clear enough. So let's just grab a random row here. So this particular product had 10 square feet, maybe, who knows, of shelf space, and sold $190, thousands of dollars. It's not made clear here, but that one row represents a product that was given a certain amount of shelf space and the sales were recorded. And we have here, who knows, n equals what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 observations from this bivariate data set. Both of these guys, notice, are bivariate numerical data sets. All these variables are numerical. Okay, so this is the type of scenario that we're talking about here. So bivariate data is the basis of all the techniques we're going to do in this section. So watch part 2, where we'll continue talking about ways to explore this type of data.